Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, I often get people emailing me saying, Neil, why don't you get a transcription for every podcast episode? And our company can do that for you. We can take all that heavy lifting off your hands. But as soon as I explain, well, I do publish 31 episodes a month, they quickly say, I don't think it's financially viable for either of us, and they disappear into the night. But I then turn to technology to try and automate a transcription of these valuable conversations that we're having. And the reason I say that is one day I would love to turn some of the biggest lessons that I've learned from over 1,200 conversations and put them into a book. So transcribing every episode would make that job a lot easier. But I quickly found that many of them out there are just not accurate enough, and you end up spending longer trying to correct mistakes. But then I recently came across a tech startup that gave me a little hope. Because Deepgram is an automatic speech recognition startup that uses end-to-end deep learning technology to train speech models to learn under complex, real-world conditions, regardless of a customer's unique vocabulary or accent, or even acoustic environment. And what they're doing is an entirely new approach compared to all the other players in the space. So today, CEO Scott Stevenson is going to join me on the podcast to share the story behind Deepgram, which, believe it or not, began in a bunker 2 miles underground. Now you're intrigued, right? So buckle up and hold on tight so I can beam your ears all the way to San Francisco, where Deepgram CEO Scott Stevenson is waiting to speak with us now. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, thanks for having me on. I'm Scott Stevenson. I'm CEO and co-founder of Deepgram. And at Deepgram, we build enterprise speech recognition using AI. So we use end-to-end deep neural networks in order to build models that learn your jargon that you use at your business, in your calls, in your call centers, or in your meetings, your acoustic background, accents, and things like that. And we do it at a really large scale.
Fantastic. And like you said, Deepgram is this automatic speech recognition startup that uses end-to-end deep learning technology to train speech models to learn under complex real-world conditions, regardless of a customer's unique vocabulary. And I think that's more important more than ever now, and getting over things like accents and product names and acoustic environments. But can you tell me a little bit more about this entirely new approach that you guys are taking compared to the other players in this space, such as Google, Amazon, and Nuance, for example?
Yeah, absolutely. It pays to take a step back and just look at like what are they doing, or what was the approach that other companies have been taking in the past and are still taking currently. And the way that this worked was you had, and this dates back all the way to the 80s too. So it's a similar architecture to what was being worked on in the 80s. And then it was, tuned through the 90s and like sort of made to work. And then in the 2000s is when it had commercial viability. And then now these systems still stick around there. And so the way that this goes is you have like a heuristics-based set of programs that ingest audio. So you have to think about audio as, hey, it's just a recording, that's a waveform. And although there's people speaking inside it, there's nothing except for the waveform. There's no words, there's no anything like that. And that's the job of the ASR system, is to figure out what was said inside. And the way that these systems were built in the past is you would have like a few steps. They wouldn't try to do it all at once. They would have a denoising step that would try to remove like 60 hertz hum or other normal backgrounds like electronic noise and things like that. And then there's a step after that where this denoised audio gets fed into what's called an acoustic model, which which has its job essentially is take that audio and then guess phonemes. So phonemes are like the alphabet of spoken words. Okay. And there's about 40 of them, at least in English. Yeah, but every language there's somewhere around that, like 30 to 50 or so. But these acoustic models, every like 25 milliseconds or around that amount of time, try to guess like which phoneme is happening at that time. And actually it's a little more complicated than that. They don't guess only a single phoneme. They guess every phoneme every like 40 milliseconds or so. And so anyway, it's like it's trying to feel its way through, what phonemes could have possibly been said. And then the next step after that is what's like a hidden Markov model or a weighted finite state transducer. But anyway, its job is to take all those phoneme probabilities and then say, what are the word probabilities as a function of time? And so if you have like a 10-minute call, maybe 1,000 words were spoken between the two people. But that first step of that acoustic model will turn it into like 80,000 different possibilities. But then the next step after that with that hidden Markov model will turn it into like 800 million possibilities. And then the next step after that is like a beam search and a text-based language model that folds it down into, okay, we have to throw away all tons of information because there's 800 million possibilities, but I know there's only around 1,000 words, and so you have to start hacking off a bunch of words and then say like, finally, here's your transcript. And so this was all built by speech engineers, like laboriously over a long amount of time, academics, spending like countless man hours in order to build these different systems, and they were the best for a long time. But now end-to-end deep learning is definitely the best way to do it, where instead of having people sit down and try to figure out these heuristic rules and then work through that pipeline of the acoustic model and the hidden Markov model and the text language model, that sort of thing, you don't do that anymore. What you do is instead present an end-to-end deep learning model with the recorded audio and the answer, which is basically the transcription. So you say, hey, here's the audio and here's the real transcription. Now you learn the rules in order to convert that audio into that transcription. And then you do that on millions of examples. And you do that over a long amount of time because it takes a lot of power and time in order to train these models. But once you've done that, you've taken the speech engineer out of that equation. You're not biasing the system. You're not slowing down the training of it or anything like that. And that's really like the difference here. So DeepGram does end-to-end deep learning in that way. It's a fully machine learning based approach where you remove those in between steps. And so for us, we just present a deep learning model with audio, and then it does its calculation all in one, and it's everything happens at once, and then the words come out of it. And this makes it faster, and it's not like 10% faster. It's like an order of magnitude faster. It makes it more accurate, and it gives you the ability to train a custom model easily, because the old way of doing speech recognition was it was very time intensive, as you can imagine, in order to build these like pipelined models using the old style. But for an end-to-end deep learning model, what you do is use what's called transfer learning. So you have a general model, it maybe took years for it to get really good, but then when it needs to learn about a customer's audio, it might take a couple days for it to switch. So it's a lot like somebody who went to college and took a lot of time to learn about the world. But then they go to their first job, and then they start specializing in their first job, and then they get really good at that job, essentially. So hopefully that gives you a good idea.
Absolutely. And one of the things that I'm fascinated by recording this daily tech podcast and speaking to startups from all over the world is the story behind them. And when I did a little bit of research before you came on today, I learned that you came up for the idea of DeepGram while researching the creation of dark matter in a bunker 2 miles underground as a PhD student. But can I ask that you share that story with people listening today?
Yeah, yep. I mean, it's true. It's very interesting. It's like you're living in a James Bond lair. So Like, I mean, there are cranes and yellow railing everywhere, and like, that's it. That's how it was. But yeah, the what we were doing is building a deep underground dark matter experiment. The reason you have to go underground is because you're running away from cosmic radiation. Basically, everything is radioactive. You're radioactive. I'm radioactive. The things we eat are radioactive. Like everything is radioactive to a small degree. And radioactivity is raining down from the sky too. So these detectors are so sensitive that if you put them on the surface of the Earth, then they would just light up like a Christmas tree. It would be too noisy for you to read anything, and so you have to go deep underground, and that's why we were there. But nevertheless, when you're taking that data and building that experiment, you can imagine it's pretty complicated. But once you actually get it working, you're kind of sitting around twiddling your thumbs. You're waiting for it to take data because you have to allow the experiment to be exposed to the dark matter that is flowing through it. And so you do this for like months at a time. And that's the time where you have a lot of time on your hands. So you're playing ping pong, you're building drones and things like that. But the thing that got us into audio was we thought, man, it would be really cool if you made a backup copy of your life. How would you do that? Could you do it with video? Do you do it with pictures? And then, we're like, nah, the way to do it would be with audio, or at least to start. And so we built these devices that record audio all day, every day. It's just like another, similar to another cell phone, about the same size and everything. But we just built them, with a battery and a little CPU on it and a Wi-Fi antenna. And its sole job in life was just to record audio all day, every day from its microphone, and then upload it when it attached to your home Wi-Fi. And so we did this while we were working on this experiment, and ended up after a few months collecting hundreds of hours of audio, and then realized that it was like really hard to go back and find anything interesting in your life again, because as it turns out, like there's a lot of dead air. There's a lot of things that aren't, that you don't want to sit down and listen to, and you're not going to sit down and listen to your life again. Like that's crazy, right? So you want to find some way to find the interesting moments inside. And that was really what sparked the idea of, man, a lot of the stuff that we're doing in particle physics could be applied to that problem of finding interesting moments in speech.
I love that story. And if we fast forward from that moment, from where you were 2 miles underground to March this year, just before everything started shutting down, you secured $12 million in funding. So you can tell me about that and how that funding is going to help you move forward and how you're going to put it to use?
Yeah, absolutely. So Deepgram is a true AI company. And what I mean by that is that we label our own data, we train our own models, we build our own infrastructure to do that, and we host our own scalable API to house those models, and whether the cloud or on-prem. But that type of company takes a little while for it to get off the ground. So actually, Deepgram is about 4.5 years old, and we raised our seed, about 4 years ago. And now we just recently raised our A of 12 million. So what were we doing in the in between? So yeah, we were building the tech and proving out the market essentially, and the market was sort of growing up alongside us as well. As a lot of people can imagine, like 4.5 years ago, like Amazon Echo wasn't that popular. Google hadn't released a speech API or anything like that. So it was sort of still the dark ages in speech. But anyway, so previous to us raising our Series A, we dumped tons of effort into the tech side of building this, very complicated new tech for speech recognition. But now we've gotten to the point where the market is great, the tech is de-risked, and so we're actually really going to market. Whereas before we didn't do marketing, we didn't do anything like that. Now it's okay. The world needs to know who you are and what you do, and that's actually that's the biggest piece is sort of marketing, sales on the go-to-market side, and the customer success. Because actually, a company like Deepgram is And there will be a new wave of AI companies that are like this, where they become so effective, and actually their margins are better than previous companies because of like better tech and speed and things like that. So now you can redefine what it means to be a speech recognition consumer, what it means to buy speech recognition and use it at scale, or to build new apps. And that's really what we're doing. We're building the speech company, and what that means is putting in effort on these other sides that we were sort of, not paying attention to before. So that's what the A is about, is building that side.
And if we do have any business leaders or decision makers listening, do you have any examples of how you're helping enterprises unlock the potential of audio data with this custom trained speech recognition built for accuracy and scale, just to help them understand the value that it could bring to their business?
Yeah, absolutely. There's two types of customers that DeepGram works with. Generally, we're working with mid-market or enterprise companies, but they fall into two categories where, put really simply, it's like, hey, you're an enterprise that has a call center, and you have data scientists that have power at your company, that they have budget. Your company thinks about making decisions in a data-driven way, where, hey, we're not going to make a big strategic move unless we have data. If your company is thinking like that, then and you have a call center, then you're probably also looking at your voice data and saying, wow, this stuff is really valuable. And how do we train our customer service agents better? How do we make sure that we're compliant? How do we do market research on that data? And really just sort of overall, with the new revolution that's happening in enterprises in that data science way of thinking, they're saying, hey, we have all this valuable data, and we may not even know exactly what we want to do with it, but we know that if we convert it into a format that our data scientists can use, and then house in a data warehouse and make it centrally available to anybody who wants to use it across the organization, then we're going to get good value from it and good data driven decisions made from it. So that's one type of customer. And it can be banks, finance, it can be retail. It's pretty wide reaching. Many enterprises have call centers. And then the other angle here is a voice platform. So think of all the meeting companies in the cloud call center software. And these companies are like really booming right now because of COVID. And anyway, there's been a big move to the cloud in the past anyway, and a revolution in communications for business communications, and all of that's moving to the cloud, and just better products are being built. And so they're looking at that. These communication companies are looking at the world and saying, man, we made video quality better, we made audio quality better, we made lots of different products in the past, but we still haven't made anything that a human can interact with, like a machine that a human can interact with as if it's a human. And that would bring tons of value. And so they're thinking AI, they need to bring AI into their companies. And so it's those two types of companies that get a lot of value out of DeepGram right now.
And I'm curious, 2020 has been an unusual year, to say the least, and very unconventional. But are there any trends that you're noticing from the conversations that you're having with your clients, and the kind of thing that they're coming to you and asking for your help with?
One thing that we're noticing is that real time is becoming a thing. And what I mean by that is, in the past, for speech processing, it was thought to be too hard, and it definitely valuable to do real time, but too hard. And what I mean by real time is having a conversation that is happening like between an agent and a customer, and having that ingested in real time so that something can be learned or interjected into that conversation. And I'm not necessarily saying like, hey, you have like a synthetic voice, like interject into the conversation or something like that. Generally, it's more subtle than that, where like the agent will be on their computer, headphones on, microphone, and they're working in their like CRM or their knowledge base. And DeepGram is working in the background, transcribing the audio, and we know like this comes from the customer, this comes from the agent, et cetera. So you know who's saying what. And then on the screen of the agent, there will be just like a tenth of their screen that's taken up by a widget that is suggesting them like articles that may help them from their knowledge base. Like, for instance, a person's calling in and saying, hey, my iPhone 11 Max is broken. I can't do something on my operating system. And DeepGram in the background is transcribing that with only like a couple hundred millisecond latency. And the agent screen is being populated faster than they could ever search for anything. And so what this is doing is like eliminating that bear with me moment in that we all experience when we call call centers, so that they have information presented to them faster than they could ever search for it. So this is something that's definitely it's cropping up recently, and I think this is because customers and just generally the world is getting more comfortable with voice, and it is complicated, and you can't see it, or you can't see it, but you do know there's a lot of value there. But these big companies are like, wait a minute, if we can affect the conversation as it's happening in a positive way, then you see like big gains. And this might be like literally customers that have implemented this see like a 20% increase in their sales and when they're using the system and that sort of thing. So yeah, this is definitely a new, bigger trend that's happening.
And there really is a lot of excitement in this space at the moment. And for many business leaders, they may think it's quite a crowded marketplace with Nuance, Cisco, Google, Microsoft, and Amazon all offering real-time voice transcription and captioning services, along with up-and-coming startups such as Otter.ai. But for those people listening that are bewildered with all this choice, what is it that you think that makes you stand out from the crowd, would you say?
There are two big things, and that's accuracy and scale. And the way that we achieve accuracy is using end-to-end deep learning for our general models. So our general models are basically just as good as Google or Amazon on these standard tasks that we're talking about. But the real magic there is that our system can learn from your audio to get much better, get drastically better. So maybe you start out, and these numbers might sound low, but these are actually real numbers where if you have a phone call, like a phone call type audio, and you were to go try Microsoft, Google, Amazon, you might start out about 70% accuracy when you actually go like really measure what your accuracy is. And for DeepGram, it'll be similar for our general model. Okay, but the real magic here is that we allow like our system is built in a way that will learn about your accents, your acoustic background, and within 2 weeks you'll be at like 80% accuracy. And there's just no way, and no dials you can turn, no amount of money you could give our competitors or anything like that in order to get that kind of accuracy. That's not where it stops, because the system can continue to learn. And many of our customers after 6 months are over 90% accuracy. And so this really speaks to like the garbage in, garbage out area for data scientists, where like, what would you rather have, 70% accurate audio or 80 or 90% accurate audio when you're trying to build models based on speech recognition? It's a drastic difference. So that's a big one. That's the accuracy story. But on the scale side, speed, this is one thing a lot of companies don't necessarily think about yet. They think about accuracy like right away. But now when this is a strategic move inside your company and you're thinking, hey, I've got 150,000 phone calls every day coming in, that's a lot of audio. And that is really difficult to get transcribed using the old techniques because they're very computationally intensive. They take up a lot of memory. And so like if you were going to go do this with a CPU based system, and whereas DeepGram is a GPU based end-to-end deep learning system, if you're going to try to use like the old style system and just use CPUs, you'd have to have like another data center, and it's like, whoa, that's a lot of effort in order to get that going, and it's a lot of total cost of ownership. And so for us, with the side benefit of using accelerators and end-to-end deep learning, you make it just way more cost effective. And so true real numbers here, like half as much are very typical at scale for DeepGram. So yeah, that scalability, the speed side on that, being able to do real time and everything that matters, and then also that accuracy.
And I have tried some of those other services because, like, as you know, I host a daily tech podcast. So I've tried to sample some of the transcription services out there. And like you said early on in your comment there, a lot of them are 60 to 70%. And when you spend more time correcting everything, it's just not deemed worthy. So I know what a big deal it is that you're doing here. But if there is anyone listening that still doesn't quite get it, do you have any examples of how businesses are using speech recognition APIs to empower their business?
Sure. Yes. One of the largest ride-sharing companies in the U.S. Uses DeepGram in their hiring process. Or maybe a better way to say this is to illustrate what happens. So, if somebody's interested in becoming a driver for this ride-hailing app, what they might go online, see something that says, "Hey, you want to be a driver?" and fill out this form, right? So they fill out the form, and then a recruiter from the company will call them and ask them questions. Like, how old are you? Do you have a car? How many doors does it have? Things like that to qualify them and make sure, like, have they had an accident in recent times or anything like that, to figure out if they would be a good fit to go on the platform. This obviously serves several functions, right? Where they're trying to make sure this person will be a safe driver, but they also have all the tools they need in order to do it, and that sort of thing. But when the company is using DeepGram to analyze this data, they're not looking only at the applicant, they're looking at the recruiter as well. They're trying to figure out, is this recruiter doing a good job? Because they have thousands of these calls happening every day. And is the recruiter doing a good job? Did they ask the questions that they were supposed to ask in the order that they were supposed to ask them? Was this a compliant call, et cetera? And then on the person applying side, is this a qualified lead? Does it make sense for them to join the platform? And can we get an automatic score from that? And so that's one use case that works really well with DeepGram. Your data science team just builds a simple model on top of the stream of speech transcription that's coming in. And another really easy use case to understand is on the side of compliance, where maybe when a call happens, you have to identify, like, what company you're from, what your name is, and then ask if you have permission for something, or say that this call may be recorded, or as you go on in the conversation, do you have permission to create an account or send you an email or something like that? These compliance type use cases are all over the place, and dangerous for a company not to heed. And so they can use this automatic speech recognition to discover those moments where it doesn't happen the way it's supposed to, so you can retrain your agents.
Fantastic. And what's next for DeepGram then? Where do you go from here?
Well, so we want to make this process easier, where and we also want to sort of educate the market, bring the market up to speed that this exists now. Whereas in the past, people thought about speech recognition as like what you see is what you get. You go around and test a few vendors and you try to figure out what works for you, and none of them are going to work really well, and that's just what you have to deal with. Well, that's not true anymore. And so you can affect the accuracy, you can affect the speed, and you could bring it on premise or you can do it in the cloud. And now it's flexible, and you're going to have a partner in doing it too when using DeepGram. So bringing that to the world is our big focus, and really that fits into the vision for DeepGram to be the speech company and bring speech understanding to the world, because that's really what these companies are buying. They're not buying transcription so that people can sit down and read it. Usually what they're doing is buying transcription so that they can understand what's inside their audio, and we are powering that revolution, and like there will be more to come from DeepGram on that front. Our primary product right now is transcription, and that's how everybody should get started. But after transcription, you're generally thinking of what are other things what are other pieces of information that I could get that would tell me more about what's happening in this call, like which speaker is speaking when, or are they speaking a different language? And that's like really important if you have a global meetings company, like just knowing which language they're speaking so you can give them the right automatic speech recognition model. Like that's not a thing that's really built anywhere yet, but these types of things are coming from DeepGram in the future.
And speaking of the future, anyone that'd like to follow your progress or just find out a little bit more information about everything we've talked about today, can you just point everyone listening in the direction of where to find and follow DeepGram online, and also contact your team if they've got any questions?
Yeah, absolutely. So deepgram.com is where our website is located. You can learn more about DeepGram there, and contact us on the website, or at DeepGram AI on Twitter is a great place to find us.
Excellent. Well, I love the story that you've been on, especially that starting the creation of dark matter in a bunker 2 miles underground to where you are now. I think it's an amazing story. It really is. But I'd love to continue to follow your progress, maybe get you on again towards the end of the year or early next year, find out how that's going. But more than anything, just a big thank you for sharing that story with me today.
Yep, thanks, Neil. I appreciate it.
For me, this was a tech startup story that had it all. I mean, I love the idea. The idea for it came from being in a bunker 2 miles underground. And I also love that they're solving a real problem with technology. So congratulations to Scott and his team at DeepGram for securing that $12 million in funding. This is a project I will be watching very closely. But over to you. When it comes to transcription, voice technology, automatic speech recognition, whatever it is, I'd love to hear your thoughts. So please email me, techblogwriter@outlook.com. Remember, my website is techblogwriter.co.uk. And you can find me on LinkedIn, Twitter, Instagram at Neil C. Hughes. But don't just mindlessly hit follow. Send me a cheeky hello, I listen to the podcast, just so I know who you all are. And if you're not on social media, I've got another little favour to ask you. Would you mind leaving a quick rating and review of the podcast on whichever platform you listen to? Because just like every other podcaster out there, I'm a slave to the algorithms, and those algorithms will determine which podcast slides up and down the rankings based on how many ratings and reviews you get. So I'm not a big fan of digital begging, but if you do listen on a regular basis and you enjoy the show, I'd appreciate you leaving a quick rating and review. But that's it for today's episode. I will see you all again tomorrow, but a big thank you for listening. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.